I hope that you're getting a sense of how radians work, and like getting a bit more used to them, maybe a bit more used to their fraction nature, how we examine them as fractions. We're always dealing them with fractions, because that's going to be really important for what we're doing over the next few days, is having a better sense of what the radians are, but also how to work with them as fractions. So later, we're going to, like, a couple of the questions that we're going to look at are going to be kind of tricky, I think. But in your head, try to realize that probably the trickiest part of this is the fractions. It's not even just the radians, it's the fractions, and it's like, that's elementary school stuff. That's grade 9 stuff. We talk about fractions, right? But it's one of those things where they always plague us. Thank you. We don't deal with them enough, I guess, that they tend to be tricky, right? So I think it helps when you're identifying, well, why am I finding this harder than normal? I'm not saying that you will. Maybe it'll be fine. But is it just the fraction part of it? Because if it is, then just be aware of that. Okay, so first of all, what we're going to look at is here are our sort of base functions with the transformations. A sine k, this might have big brackets around it like that, right? Times x minus c plus d. Or if it's cosine, which one it is will make a big difference. We're going to see that as we're examining the graphs. And so here's a quick summary. A changes the amplitude. Think about what the base amplitude, what is the amplitude? It's half the distance from the max to the min of a periodic function. In grade 11, you probably looked at just like random periodic functions, so not sine and cosine, ones that don't really have an equation, but there's a graph and it's periodic. And then you talk about what the amplitude is. Half the distance from the maximum to the minimum, that's the amplitude, right? So A changes that. So for just y equals sine x, which we have here, I can see that it goes from 1 to -1, the base graph. So that's a distance of 2, so half of that is 1, so the amplitude is 1. The other way to think about it is from the 0 line, okay, which is like the middle of the max to the min. The amplitude is the distance from the 0 line to the max and also the distance from the 0 line to the min. So it's sort of two different ways of thinking about amplitude there. What does the k do? It changes the period. Remember, you have to remember these little formulas. So to find the period, you take 360 and divide by, or that should be in radians, 2 pi divided by k, right? That's how we used to do it, 360 divided by k, but 360, 2 pi, same thing. So 2 pi divided by k if you're given the k value. If you're trying to find the k value, then I would take 360 and divide by the period. So I'd have to know the period, figure that out, and then I can get the k value by seeing what has happened. So, or this would be 2 pi, obviously, divided by the period. And it has, just like with all other transformations, when k is like 2, like a big number, that compresses the period. That would cut it in half. So if my regular period is 2 pi, right, one full revolution, one full cycle is 2 pi, and k is 2, then all of a sudden I would compress it into 1 pi, or 180 degrees. Okay. C is the phase shift. So for today, how would I find the phase shift? Oh, that's not right. Find 2 points, subtract, start from stop. That's for period. That should be in period. How do I find the phase shift? Well, we'll talk about that when we get to an example to make a bit more sense. But you're just looking, if it's sine, you're looking for the point where sine starts. That's closest to the y-axis. If it's cosine, same thing. Where does cosine start? You're looking for that point that's closest to the y-axis. This bullet here that's out of place is describing how you would find the period from a graph. Find the same point that's repeated in the cycle. right? So find one full cycle, 2 points. Where does it start? Where does it stop? One complete cycle, and subtract to find the length of the period. And then finally, D, these are obviously just in order from left to right, not necessarily the order that we think about them. D changes the zero line. So again, if I'm looking at the graph, there's the zero line of sine. What's true of sine? It starts on the zero line. The base function goes to the max, passes back through the zero line, goes to the min, and then ends on the zero line. Okay? And so if I have a +3 or a -2, that's moving the zero line. Just like all the other functions that you look at, doesn't change the shape, just moves it up and down. So there's sine. Cosine, same thing. Zero line for the base function is at y = 0. But cosine is different. It starts at the max, passes through the zero line, hits the minimum in the middle, passes back through the zero line, and ends at the maximum, which is 1 amplitude from the zero line. That's stuff that we need to know. Lots of patterns going on here. This point for both graphs is halfway between these, and then these are halfway between those points, or a quarter each, right? So notice that this is a distance of 3 squares to get there, 3 squares to get there, 3 squares to get there, and then 3 squares to get there. So when I get my scale, it's like the same number of squares, same distance between each point. Those are our critical points. That's how we graph. So there's 5 for these guys. Any questions so far? And then when that's like from grade 11, and then when we compare it to this year with radians, what changes? Well, I mean, nothing really except our scale and how we label it. But the amplitude obviously doesn't change. It's still 1 and -1, right, as my max and min. But this first critical point, aside, so the start is the same. First critical point happens at pi/2. That's like our 90. And then at pi, that's like our 180. And then it ends at 2 pi, right? That's 1 full cycle, 1 full revolution. So thinking about trying to relate the graph this year with radians, comparing them to the graphs from last year. So here's a question, something tricky to think about. This is where I think it starts to get tricky. What is my scale here? What am I counting by? What are my x's counting by? What are my y's counting by? I'm going up by 0.5s. 0.5, 1, 1.52. What's my x scale counting by in the top one? 30. How'd you get that?
It's like 3 spaces to get to 90.
Good. So 90 divided by 3. What about in the bottom graph? What am I counting by? Sam? pi/6. How'd you get that? pi/2 divided by 3. Fraction math. But in your head, I think you see 90 divided into 3 equal spaces is 30. When you look at this, and if you do, that's fantastic, but I can imagine that many people wouldn't look at pi/2 and just go, oh, it's counting by pi/6s. Like it doesn't jump out at you. Maybe you even need to pull your calculator out and think about it or scribble something down. Now, when I do this math, like there's lots of different ways of thinking about it. It ends up being pi/2 times 3, which is pi/2, divided by 3. It's pi/2 times 1/3. So I multiply. Remember how we talked about this the other day? It like joins in on the bottom. Dividing by a number like that, it joins the denominator there, as long as it's not a fraction. So it ends up being pi/6. So you can just kind of do it that way, right? We did end up multiplying 3 by the denominator. So there are like different ways you can think about it. But that's going to be a key aspect of graphing with radians. Is the hardest part is figuring out the scale probably. It's true of grade 11, and you're dealing with degrees, and in grade 12 with radians, with fractions, that much harder. Okay, so keep that in mind as we're going through. thinking about how we figure that out. Oh, and one more thing. So then this is what I like to do. So when I've got it, okay, so pi by 6. So this is 1 pi by 6, 2 pi by 6, 3 pi by 6. 3 over 6 is a half, so that's like pi over 2. You see that? Does that make sense? 3 pi over 6 is the same as pi over 2. Okay, 4 pi by 6, 5 pi by 6, 6 pi by 6. That's pi. 7, 8, 9, 10, 11, 12 pi by 6. That's full 2 pi. Right? So kind of thinking about counting squares that are size pi by 6. Okay, so let's take a look at what our practice is going to look like today, what our problems are going to look like. For each of the following, consider the indicated trigonometric ratio. So what it's telling you this. So we're going to do sine x for this first one. Looks like a sine curve, so that kind of makes sense. And determine each of the following. What do we notice about the first one, though? Oh, it's in degrees, so it's old school. So we're going to determine the amplitude, the translation, the period, the range, the reflection, all of these things. You don't have to do them in this order, but like they're not really ordered, but I mean, you kind of end up having to do it somewhat in this order. And once you've done a few of them, all of a sudden the rest of them kind of fall into place. So let's find the amplitude. So I'm going to just start looking for key areas or properties of this graph. I know that sine starts on the 0 line, right? So again, I'm kind of doing it out of order because, oh, that's the next part, the vertical translation, right? But I'm thinking about that, and then I'm looking at this scale. So this is 1, and so I've gone up how much and down how much. Or I can think of the full change. This is like -2.5 to a half, which is a distance of 3. Half of that is 1.5, right? So my amplitude in this case is 1.5. And it doesn't say to do this, but I'm going to add this in and just think about it. This means my A value is 1.5. Right? So a question later on asks about the reflection, but I've kind of already answered that in my head, because if it was reflected, it'd have to be -1.5. Okay, what's next? Vertical translation. So that's -1. That's where's the 0 line, and that tells me D equals -1. Or I should call that down 1. Okay, next is the period. So what's the period? Okay, so this is counting by 15s. 15, 30, 45, 45, 60, 75, 90, and so on. So 180 plus another 30 is 210, right? Because that was 2 more squares. So it ends at 210, starts at 30. So the start, you don't have to write it down this way, but we're just kind of outlining. It starts at 30. It stops 1 full cycle at 210. So the period is 210 minus 30, which is 180. And then again, it doesn't ask me to do this, but I'm going to do it. It's going to help later. What is my K value? So K is equal to a normal period, which is 360 over 180, which is 2. And like I said, a period of 2, K value of 2 cuts your period in half, right? That's compression. That makes sense. That should make sense to us. Good so far? Any questions so far? Okay, range. y is an element of the real numbers such that it goes down to the minimum value, which is negative 2.5, less than or equal to y less than or equal to my maximum value, which is 0.5. And my domain, so this is out of order, but that's fine, is x is an element of the real numbers such that, see, I've already done this. Where does it start? So domain of one cycle, it asks, I believe, right? So 30, because it's periodic, so it goes on forever, and you could do other cycles, but we're just going to do this basic one that we already found. From the start to the stop. Not reflected. Again, we've already thought about that with our A value. Phase shift. So it's 30 to the right, which means my C value is 30, which means it's going to be like x minus 30, because it's x minus C. Again, you don't have to do all that, but this is where the thinking happens, to find all those values so that we can do this last thing and write the equation. So what's the equation for this one? Y equals A, 1.5. And this was a sine curve, so sine, bracket, my K value, bracket, x minus 30. See, I've already done all the work. So it's easy to write the formula. Any questions about any of that? Go back up to this list of how the amplitude and A and the reflection are related. K and the period are related. How you find that by finding the phase shift, the start and the stop, like all of these different ideas, how they're related to the graph and how they're related to those values in the equation. And as I'm going through this and doing things like finding the amplitude, connecting that to the equation, that's what today is all about. Except we're not doing it in degrees. That was our warm-up. We're doing it in radians. So let's take a look at this guy. It says it's cosine. So what jumps out at you? Kyle? It's reflected, yep. Anything else? Scale is different. Okay, so I mean, for everybody it might be a bit different. I would start looking for the points. So I counted 1, 2, 3 to get to this point, 1, 2, 3 to get to this point, right? 3 to get there, 3 to get there, 3 to get there, and 3 to get there. So I found all my points. There's my zero line. That's my vertical translation. Okay, so we start with the amplitude. So this has a max of 3 and a min of -1. And the zero line happens at +1. So +1 up to 3 is 2. +1 down to -1 is 2. So my amplitude is 2. Halfway between the max and the min, or the distance from the zero line to the max, or the zero line to the min, which means my A value is -2 because there's a reflection. Do that now, or you can do that later when you do reflections. Vertical translation is up 1, so my D value is 1. Period. Where does it start? It starts at 0. Where does it stop? At pi. So my period is pi. So my K value is 2 pi over pi. Pi's cancel, and it's just 2. That should always happen. Our K value is typically like a fraction or a number. It doesn't have a pi in it. What's next? Range. So we already talked about this from -1 to 3. Domain. Zero is less than, is less than or equal, got them both backwards. Less than or equal to x, less than or equal to pi. See how to find the domain? We basically have to find length of a period and the start and the stop and all that, right? And the phase shift. Reflection. Yes, reflection. Hence our A value is negative. Phase shift. 0, right? How do I know that? Because I found that starting point of cosine and it's on the y-axis. And then last, the equation. Y equals, go ahead and try to write that. This one's cosine. 2x, no phase shift. 1. Questions? Comments? Anything? Okay, 2 more. One's sine, one's cosine. I'm going to let you get started a little bit on your own to start thinking about the pattern, see what you can come up with. The other thing you could do, some people might like to just write A equals K equals, that one takes some calculation, a little bit more work, but C equals D equals, like maybe you write those first and then use those to get the amplitude. Use that to get the phase shift, right? Like think about, and the start and stop, that kind of thing. Like maybe you do it in that order, I don't know. What do we have to do differently from this one is because, and you'll see the work is on the back of your handout there. There's 6 graphs that you have to do. And it's kind of like the first one's obvious. It gives you the points, and then it gets a bit less obvious. And like you can see that this one has a red, yours is black and white, but if you look at mine, it's like red, like there's your cosine. There's one cycle of cosine. But it continues, right? So that purple dotted line shows you where it would continue to go. And then these next ones, obviously, this is like, there's no restricted domain. It's just the curve repeating over and over. So how do I know where it starts? How do I know when it stops? Our rule of thumb is that you pick, so this is for sine, is that you would pick a point closest to the y-axis. So where does sine start? It starts on the 0 line. So you kind of have to determine where that is. So I'll let you think about that. Try that. See if you can draw in the 0 line. Is that it right there? Do you find it at 1? There's 2 possible starts. One of them is there, and one of them is there. The second one is closest, so that's the one that I would like you to pick, which means we have a reflection, right? So there's no like rule that there is a sine curve that is reflected, because if you change the phase shift, if you change where it starts, then it's not reflected. And that's fine. You could write many different equations for any periodic function. That's what it means to be periodic. Every time I add a period, I get back to the same place. The reflection and the phase shift are certainly related, so that you have to be consistent. But as a general rule, I would give you a graph like this, wanting you to say that there's a reflection. That's the point, if it was on a test. Okay? Okay, so give it a try. Okay, who can tell me the amplitude? Somebody too busy working. Kyle. 1. And there's a reflection. So my A value, Vivian, what do you think? -1, thank you. What's my vertical translation? Ross, what do you think? Up 1. So my D value is? 1. Easy enough. Yep. Good. How many people have already finished this question and written the equation? Okay, a few. Okay, that's fun. Okay, so just stop for a minute, put your pencil down and watch. Hopefully you kind of have started to think about where the start and the stop are. How would I do this? Well, I would look at my scale. It's counting by pi in 1, 2, 3, 4, 5, 6 squares. Not squares of rectangles, but you know what I mean, right? So that means every one square obviously is pi by 6. 1 pi by 6, 2 pi by 6, 3 pi by 6, 4 pi by 6, 5 pi by 6, 6 pi by 6. You can tell this one's going to be stretched. Okay, so that's 1, 2, 3. It starts at 3 pi by 6, which is actually pi over 2. But it's fine to leave it as 3 pi by 6 for now, but you should be thinking about reducing it as well. You should be trying to do a bit of both. So then where's the stop? So let's see, I started here and I went all the way over and it looks like I'm back on the 0 line right there. So there's my stop. So this is 4 pi by 6, which is like 4 pi, which is like 24 pi by 6. So 25, 26, 27 pi by 6. See how I break it up and then I sort of think about how I'm counting. You could also count by pi by 3s, you could, by pi by 2s. You could kind of break it up and do that. It would work. So if you think about it a bit differently, that's fine. And then what does this reduce to? Divide the top and bottom by 3, and I get 9 pi over 2. So what's the period? 9 pi over 2 minus 1 pi over 2 is 8 pi over 2, which is 4 pi. How many people got that as the period already? Pretty good. Which means my k value is 2 pi over 4 pi, which is gone, right? And 1/2. So see how that usually works out that way. All right, what's left? What have we done so far? We got to do the domain and range and the phase shift. We've already got the phase shift, but we've got to write it down and then write our equation. Okay, so why don't you try to do the domain and range? So my phase shift is right pi by 2, right? Which means C is pi by 2, which means it's going to be x minus pi by 2. So write the equation y equals negative sine 1/2 x minus pi by 2 minus 1 plus 1 up 1. Any questions? All right, let's try one more. So this one's cosine. right, fantastic. This looks great. I'm impressed. Okay, so if you want to take a look at my work, compare yours, but walking around, a lot of people